There we go. Okay. So some of the topics you guys touched on earlier was talking about what important port numbers are for servers. For like, she had mentioned that she wanted to potentially asking us like at least name 2 of them, or what are these 2 numbers associated with. I want to try and create like a simple JSON text protocol, like detailed, explain it. I want to try and demonstrate how to implement that, both on a actual Gradle side, but also I might try and touch on the protobuf stuff and implement it in protobuf, but depends on what you guys are thinking and how long it took to do the JSON one. And then we also wanted to touch on gRPC. Aside from that, I'm going to scroll over some of these main topics. Are there any of these topics that you think would be important to go over, things that we should touch on? Yeah, if you guys have
Definitely the query strings.
Okay.
As was said earlier, that's absolutely going to be a question on the exam.
Okay.
I would be willing to bet money on that. I would also think we probably want to touch on let's go with one module at a time, actually.
Mm-hmm.
Probably the lower level layers, just the basic definitions,
Yeah.
TCP, UDP, all that stuff.
And
Just go one module at a time, I think.
I'll probably also tie that into Wireshark, because I've got Wireshark pulled up, so in case we need to try out some simple Wireshark stuff. The first topic we went over was, isn't it just general
Oh man, this is such a throwback. Yeah, this is all general stuff.
Yeah, that's
About the core, Gradle, GitHub.
Yep. Distributed systems. This is a full comprehensive, right? Like the final is going over every single module and not just like modules something through something.
Yeah, it's full. It's everything.
Okay. I think this is more of how do you work with Gradle and how to work with the tools. Here's the networking layer stack. Okay, so we've got application presentation, session, transport, network, data link, physical. Application layer, or data layer in general, I believe is the stuff that we're working with when we talk with when we actually like open a socket in Java. We're basically working at the application layer and I believe presentation layer. I think Java handles the session layer, if I'm not mistaken. Because I believe the actual socket class is the one that's handling the session information and kind of keeping that session alive. And then the transport layer, what we actually, hold on. I'm going to do a simple server. this, or is it? There we go.
I think you're looking at server socket, not socket by itself. Wait, never mind. Never mind.
No worries.
Good.
Is it input stream? No, it's output stream. Okay, so quick recap. Server in Java, lowest, or not really lowest, but the pretty low down in order to do. Actually, let's just actually talk about TCP or UDP first. When you do a server socket, you are basically creating a server that runs on TCP. And so when you make a socket connection to that, you're also communicating with it on TCP, or using TCP. And to recap what TCP is, it's that three-way handshake that we went over. The what is this review? TCP being like the what is it? Your computer communicates with your, is it your router? And then the router communicates with the destination, and the destination communicates with the router communicates with your PC? Who is the third person? Somebody know that?
Just two.
It's a three-way handshake, but is it? Oh, it's three-way handshake between two, isn't it? There's three messages that get sent back and forth.
Flags.
Okay.
Yeah. The SYN, ACK, and the ACK.
Yeah. Okay, that makes sense. Yeah. I don't know why I kept confusing three-way handshake with three people handshaking each other. Which is a little bit different.
I think it's just like, yeah, if you have to remember that picture of handing the baby versus eating the baby, but yeah.
So we have a client. Okay. I'm making a quick little example on. So the server, you have a server socket, you open on the port 25565 here. You accept a new client, which the client connects by using localhost. Localhost being the computer you're communicating on, it's your local machine on that port. We then want to open the output stream, which is then going to be on the flip side. The server is going to open up its input stream, and it's going to read all the bytes from the input stream. Here we're going to write the message to the output stream. We're then going to flush the output stream and close the socket. Server is going to accept all the bytes, and then it's going to print the message. Very possible this may crash because the socket gets closed too quickly, but we'll see. Quickly on server. Oh. So run works. Build, clean, build. There we go. Just had to clean the Gradle build folder. There we go. Server received it. Okay. Super simple implementation of a TCP protocol. Now let's actually listen for traffic on, was it TCP.port 25565? There we go. So we can see the 3-way handshake right here. We have the and to compare that to the actual network stack. So we have the frame, which corresponds to the, okay, here. We have the IP protocol, which corresponds to the actual network layer. And we can see in the IP it actually just has the source address and destination address. It doesn't actually include the port numbers, which is an important thing. IP isn't concerned with port. That's where transport, I believe, comes into play. Yeah. So in the transport layer, and thus the host layer, we have the kind of the source port and destination port, as well as kind of the actual data and timestamps. But okay. And then the physical layer is the actual bits that are being sent. Okay, I think we actually she asked this in class, but just to recap, can y'all read this? How many bits are in this?
That'll have to be 64 bits.
Yeah, it's 64 bits mainly. The way to tell. This is 32. This entire kind of header is 32, and then there's 2 rows. 32 times 2, 64. Pretty simple. She grabbed this straight off of Wikipedia, which I pointed out in class. But you can tell that this is you can tell it's UDP because it's
The source port, the destination port, and the command. Yeah.
Yeah, there's no actual there's no additional information required. They're usually much smaller.
Okay, what does the checksum do again?
Checksum, I believe, is the number that you kind of increment every time. So, oh wait, checksum? No, that's the...
No, a checksum is a way to tell that all your data's there. It's like a number that there's a way to calculate that number from the rest of the data, and if the number is calculated when it receives incorrectly, it knows some data is wrong, like something's missing.
Yeah.
And it's optional in UDP.
Isn't it like the what is it? The bitwise operation between all the data and some significant bits in those data?
Yeah, some kind of binary algorithm that it's calculated based on the number of bits or like the number of
Yeah.
ones. And if the number of ones is different than what's expected, you know something's wrong, something like that.
I think they use that with backups, if I'm not mistaken. Like the way that backups are made, you don't store an exact copy of everything. You store enough bits that you can recreate everything using like bitwise operations.
Checksums don't recreate what happened. It just keys you into something's wrong.
Okay, that
Like
makes sense.
if there's a bit flip, you'll be able to tell because that doesn't add up to the correct checksum.
Ah, okay. No, that makes sense. Okay. Okay. Are we good on this? I feel like there's... I don't know. It's so abstract that it's really difficult to tie things in, especially the data link layer. Do you guys know?
At the end of the day, we just have to write this down in our cheat sheet, and we should be good to go. At least the layer stuff. And
Yeah.
the headers.
I agree. I think that, like, as long as you know, like, what part an IP is a part of, what part is, like, does the port get attached onto, what part does the destination get attached onto, what part is made out of bits, things like that. I think that's kind of most likely what is going to be asked. You guys okay to move on from this, or?
We should probably move on.
Okay. Oh, there is good points. When it comes to TCP versus UDP, which one is stateless and which one is stateful? Because if you think about it, this TCP, every time you send a message, you're increasing the acknowledgement, and there's an order in which kind of messages are sent to be correctly received, right? So that means that every message sent is based on, well,
The checksum.
okay, does she consider TCP as stateful because you increase acknowledgement after each one, or is it still stateless because you can, it's not like if you, for example, going to a website, for the most part is stateless. However, stateful is like when you're, like when we did our programs where we do the matching game, that is a stateful request where we're like, okay, we're connected, we're keeping our connection until we're finished playing the game or until we quit. And so that is a stateful protocol. Like we're assuming that we've already logged in or that we've already authenticated. Whereas stateless is like, okay, I go to google.com, it doesn't need to know any previous information, it can just do that. That makes sense.
Yeah.
I don't know if she wants protocol properties in reference to TCP or UDP.
TCP is stateful. At least it says so in my notes.
Okay. So then
Yeah. TCP is stateful. It's connection oriented, and I think
probably synchronous.
it is synchronous. Let me just double check.
Because you have to
synchronous.
increment the actual acknowledgement in order, or else, because if you have two packets with the same acknowledgement, one of them's wrong.
Yeah, and if it's connection oriented, it's going to be synchronous, right?
Yeah. Whereas connectionless, you're going to have... Is UDP connectionless though? Is it really?
Yeah, UDP is connectionless.
It's hard to.
UDP doesn't care if something's receiving; it just sends anyways.
Oh, that's what it means. So connectionless in this context is referring to you do not care whether or not the packet goes anywhere because you do not need to listen for a response. Therefore, it could be, you could be offline, you could be online. It doesn't matter. It never requires a response. Okay. And it can be asynchronous because anybody can send any message at any time during any point. And stateless because obviously it doesn't matter at what point do you send the message. Okay. What port's HTTP on? Who's got this one?
80.
Yep. Well, was it 40? I thought it was 43.
No, 443 is HTTPS. It's 80 for HTTP.
What is 43 though?
I don't know.
Oh, that's UDP. Wait, no. Wait, hold up. Okay, 43 is the TCP. Okay. It's the whois protocol. Interesting. I don't know where 43 came to mind. Yeah, but 40 or 80 is HTTP, non-encrypted, like basically website traffic. HTTPS is encrypted, traffic on 443. For HTTP, yeah. Main difference, HTTP and HTTPS, you can actually see, HTTP you can actually see the content that is being sent, as you can see right here. Whereas like HTTPS in general, you would not be able to see that. A lot of like, you'll see, if you ever look at Wireshark when you connect to a website, you'll probably see like style sheets that are non-encrypted that you can see in plain text. But when you go to something like Google or YouTube or something, you'll see all that data is encrypted. Just a interesting thing. Okay. Okay. Sockets. Yep. Okay.
You might want to do like a UDP one with the datagram for posterity.
Yeah. I'll do a datagram. What are? Yeah. Is it a datagram socket or channel? Hold up. Let me quickly go back and find my example.
Back.
Okay, it's a datagram socket. Okay, and then where is okay. Socket dot what is it? For the server, you're just gonna receive. Yeah. It's gonna receive a new. Alright. What did I do wrong here? Oh. Okay, there's a server. Data, gram, client. I'm just gonna give it port 0 to automatically get a automatically give it a random socket that isn't in use, or a random port that's not in use. Since it doesn't matter whether or not it can communicate, we're just gonna have it not care. I'm not gonna hard code it, I mean. Packet needs to have its destination set. So this should work, hopefully. And we gotta clean, we gotta build, create the server, create the client. Something went wrong. Address not sent. That's what it was. There we go. And we have a bunch of broken characters because we didn't actually fill up the packet. I'm actually kind of curious what those are, but at the same time not. Okay. For context, the server here is expecting a packet of 1024 bytes, and when it received a packet, it then put that packet into a string. So the string now has 1024 bytes in it. However, our client sent one the length of this string, which is not 1024 packets, and as a result, it was expecting a lot more data and ended up not getting as much data. So it ends up being fine. There are ways to partition this. So like the way you'd get kind of re-implement UDP almost to some extent is in this message you would put how long the message is at the very start, and then maybe you'd put like an ID and a timestamp, and maybe like a source location, like a source IP and a source port in the entire datagram packet, which is then sent to whoever's listening.
So essentially a JSON object, with a bunch of values in it.
Yeah. You can basically recreate JSON protocol, TCP protocol using UDP. It's just reinventing the wheel, right? There's the entire purpose of TCP is to not have to deal with, is to have, like we mentioned earlier, a stateful, connection-oriented, synchronous protocol. Whereas Datagram's entire purpose is to just be asynchronous, so you can constantly send messages. So honestly, you could use UDP, you can use both TCP and UDP for like games, for example. If you wanted to have like a TCP oriented game, you can have where like it's important that everybody's message is sent at the same time, and everybody's updated at the same time. You want to have TCP, whereas UDP is more for like something that doesn't really matter for accuracy, something you just need to really like, desync is okay, where clients don't necessarily receive a package.
I kind of likened it to if you're sending chat messages, you'd use TCP. Whereas if you're trying to keep track of player positions, and because that's usually something that needs to be done pretty quickly in like an online game, you would use UDP. And so you basically have the server kind of, if it loses data, it kind of guesses where the player is, and that's what rubber banding kind of does.
Yeah, exactly. It's
really.
Yeah, the important thing is like when use the right protocol in the right situation, right? When you want to make sure that you're not losing data, you want TCP. But when you want to make sure that when you're okay with data to be lost or retried, UDP is completely fine. It's up to the actual implementation details. And something to also note is that while these protocols aren't themselves encrypted, like by default, that doesn't mean you can't implement an encrypted version of them. So HTTPS is basically, you can implement that using TCP. Now, granted, you probably don't want to do that, but it is technically possible. And I think that's kind of, to some extent, what our like first like assignment 2 was all about. Was we were given a web server, something that just opens a socket, a server socket, and then parses the header as if it was HTML, or not HTML, HTTP. And in response, it kind of forged its own HTTP response. Now, there are good and bad things about that. It probably doesn't support all versions of HTTP. It's probably not going to be as sustainable and not as like you wouldn't want to use this in a production environment, but it does serve a purpose to explain like you can recreate more or different protocols or more complex protocols with simpler, lower down protocols themselves. That makes sense. But that was a big side tangent, and that's how we do Datagram server client, aka UDP. And when we looked at Wireshark, we noticed only one message, whereas TCP had a lot more messages involved for such a simple interaction. The difference of actual like length, I believe you can see statistics, conversations. TCP had a total of 388 bytes. UDP had 44 bytes. So like there's a significant difference of information that was being sent and received. And the duration of UDP was like not even, well, this is a conversation, so it's going to be 0 by default since there's no reply. But there's going to be a moderate time difference as well. But anyways, are we done? Are we good with sockets and low-level communication?
Yeah, it should be good.
Kind of have a question. What's the difference between the synchronous and asynchronous?
Synchronous is basically there is a specific order of operations. Two things cannot happen in parallel. Asynchronous, things can happen in parallel, basically. So in terms of communication, synchronous, I ask a question, you reply, that's a synchronous thing. Asynchronous is more like modern conversations where two people can be talking at the exact same time and asking a question at the exact same time. That's an example of asynchronous.
Okay.
Any other questions? Okay. I'm going to move on to serialization. Now, we've done a lot of Json serialization, which, for context, Json is just a fancy way of, basically a fancy text file that's used to format information that is used in a lot of object-oriented or applied to a logic object-oriented languages. So the example they show is like they've gotten some object. Objects are denoted by these little curly brackets. And inside of these objects you have a key that is associated with a value. And this mimics like a map or dictionary in a lot of ways. So you can use it in a lot of similar ways, where the key has to be unique here, the string has to be unique, and the value can be anything. It can be one of a few types. It can either be a string, a number, or another object or array. It can also be a Boolean, I believe. And as you can see here, address, misspelled address, is a value, has the value of another JSON object, denoted by those curly brackets. Here, employees is actually a JSON array. And you can see that each one of these are an element separated by the comma. So it's an array of JSON objects. Now, different from what you may be used to in Java, these can be alternating types. So you can have an array of an int, a string, and an object all in the same array. They do not have to be strictly one type or another. So that's something to note if you end up working with this more, which you probably will. It's basically all over. Your browser uses it for almost everything. But yeah. JSON objects, I believe it's, what is it? Is it, does anybody know the abbreviation for it? Is it JavaScript serializable object notation? I may be pulling that out of my butt. No, I was right. JavaScript object notation. That was close. Understanding a protofile, but before we actually get to a protofile, I want to show you how to do a quick Json server. So rather than this, okay, in the build.gradle, I just copy pasted the server and client for TCP and okay. Oh yeah, in Gradle we should do a JSON dependency. This can be Google JSON as it just suggested. This could also be Jack or this could also be org.json, JSON's Gradle dependency or Maven dependency. I'm going to use this one because this is the one that she uses throughout the class as opposed to Google Json. Once we add the dependency, since we have Maven Central, we can use Maven Central or Maven's repository to download it. And I'm going to do in Json Server, we should now be able to do a new JSON object, and rather than a message, we're going to receive a JSON object, and then rather than sending a string, we're going to send a JSON array or JSON object. Okay, Json Server, oh, gotta rebuild. Clean, build. There we go. And now we've just implemented a simple JSON, which I'm actually gonna put side by side. Okay. Now, abstracting from the TCP portion of this, I want to ask you guys a question about how this current interaction goes. Is this stateless or stateful? The way that this current implementation works.
I reckon it's stateful.
I think it's stateless.
Okay, why do you think it's stateful, and then why do you think it's stateless?
You'd have to have the.
Oh, go ahead.
Sorry, go ahead. You go ahead.
Dave, you
Okay,
first?
It's stateless because when you send the information to the server, it sends it back, but then the interaction is over. It doesn't remember the information you sent beforehand.
Exactly. So this server does
Okay.
not maintain any information about the client. They accept it, they receive a message, they're done. There's no more communication, their client is closed, socket's closed. Now stateful as, sorry, what is your name? I cannot pronounce your Discord name.
Oh, I should change that to my actual name, but just Coleman.
Okay, so as Coleman mentioned, the key detail here is there's no information being retained by the server, and the client immediately closes its communication. So like I mentioned earlier, this is basically like an HTTP request where you send over information, it receives that, maybe it responds back with something, and then that communication is finished. Now let's say we wanted to make this stateful. What we can do is we can make a client handler class that extends a thread, and this thread will take a socket, which is the client, and then this client handler's sole purpose is to receive JSON objects, print them out, forever. Okay. And then over in the server, we can create a while socket while the server socket's not closed, which is basically just a forever loop. We want to create a new client handler which we can make static. There we go. So now the server can forever accept new clients. I'm going to edit this configuration, allow multiple instances. Oh.
Oh, good God.
Oh, it's because the communication immediately is shut off. That's why. So because these clients immediately end their communication and they don't keep their socket open, this basically throws an error saying, hey, the text must begin with this, but the character it received is what's referred to as like an end of stream or end of file character. So let's say we want to actually start implementing a JSON protocol. Let's first actually do a protocol kind of document. So this is an informal document that we've done a couple times, but I've noticed like is a bit confusing. Basically, you're like my cool protocol. Let's give me some idea. What are we doing? What are we making?
Simple addition mechanism.
Okay, is a simple demonstration of adding two numbers. It is a JSON protocol and must follow the following format. A request, sure. A request will send a JSON that has A and B, which is 1 and 2. And the response will have a result. Errors are, sure, we'll do codes. 1 invalid JSON, 2 missing field, invalid field, valid value, valid request, internal error. Those are pretty good errors. Error response, sure. We'll do something like that. How does this look for protocol? I don't actually add type. Okay. Does it look like enough, or do we want to do anything else? We basically describe what the actual server is, the protocol description, kind of explain what it is. You have a request, so we only have one request here, but maybe kind of have sections, and maybe do something like subtract request as well.
And why not give the user the opportunity to write their numbers?
Like using user input?
Yeah, the user input kind of thing.
So the key detail here with these JSON protocol servers is we're writing this protocol so that any client can communicate with our server regardless of how that client is implemented. As long as the client follows our rules of how to make a request, we will respond with a response. So you can kind of think of it like, in theory, you could send a message to Discord without using Discord's app as a whole, but you must follow their very specific protocols in order to do so. So you may need to have your authentication. You need to have content of the message. You need to send it in a specific way over a specific channel. Like, this is basically a contract between my server and anybody who's connecting. Does that make sense?
Yeah.
Okay. So let's start off with the client handler. So we already have the ability to get a JSON message. So why don't we just start off by saying, hey, does it have a type field? Because if it doesn't have that type field, then we probably want to respond to them with something. But it's going to get a little bit weird to like create a new JSON object and send that over and whatnot if we just keep copying and pasting, and it's going to get messy. So what I'm going to do is I'm going to make some helper methods. So public, even just private, JSON, not even JSON, just void respond, and we can respond with a JSON object. So we'll write out a message and flush that out. And even more with that, we'll respond error. And given a message and a code, we'll create an object with type error, as we mentioned here. And we'll set the code, which this isn't right. This is just Copilot messing up. So error, and then we're going to put the code here. And then the message right there. We'll make this have the throws exception, and then we'll do a respond add. So given a JSON object with a request for adding things, we will see if the request has an A key, or if it does not have an A key, because if it does not have an A, then we need to respond with an error saying, which, what is this, missing field? Missing parameter A. And then we want to do the same thing for B. And then finally, we want to put a new JSON object with the result that is of A plus B. Pretty simple. Which we might also want to do right before this, rather than if statements like this. This is else if I meant. Is there no checking for the type? Do you guys know how to check if there's an integer in this library? Like if the key is an integer?
I think you just have to check if it has a particular value.
Yeah, but
And we can
you want
like a has int function.
There's no has int. That's the problem. There's
So I
get
guess
int.
like we can assume, yeah, there's get int, and you can directly get the integer value instead of having to like get the value and then like parse it into an integer. But you don't have to do that. You could just check if it has an integer value or
This
has
is how it does
int.
it. So looking at the actual implementation, they get the object and they see if it's an instance of number. Okay, so if request dot get a instance of integer, we can say, hey, they don't have, it's an invalid field, the parameter is not a integer. Same with B. And so now we know that A is both part of the request, it's also part of the, it's also an integer. We do know the same with B. You know, B is an integer. And finally, we can, oh, we should also return. I didn't really remember to return. Okay.
Wait. You're saying if the request is an instance of integer, then you throw an error?
Oh, you're right. Good catch. You want to flip that logic. Which actually, you want to see a cool trick? You can define the variable here by having this as an inverted instance of check. We know that everything past here, this variable A has to be defined, and therefore A now exists as a variable.
Someone posted it.
You be listening to your thing.
I'm gonna just FYI, Derp, you're not muted. Alright, so the result is A plus B, and that's the add. Let's quickly do the it's actually private void or boolean validate. I don't know, validate math operation. Not this. We're just going to take this. I'm going to copy paste this. Turn false. I'm extracting these if statements into a method, so that way we can quickly validate the math requests. So now we can do private void respond subtract. Plus given B. Okay. Respond error. So if the message we receive from the client does not have, or is an invalid request, no, it's actually if it's missing a field, missing parameter type. And then we'll return. And then if message dot get type instance of string what is this, yeah, so if it's not a string, then we're going to return saying, hey, parameter type is not a string. We're going to make a switch statement for the type to say, hey, if it's add or subtract, we're either going to call respond add or respond subtract. Otherwise, we're going to respond with the error not invalid value on invalid request. Unknown type. Okay. Then we should probably add a quit. So you probably want to be able to stop the session. Okay, and then we'll do a okay. And if this case is quit, spawn quit and quit out. Cool. And not only this, we're going to break out of this. Going to break out the loop, which if you didn't know, you can label while loops and for loops, and that way you can call break statements to that specific loop itself. Super nice. And rather we do need to actually change how this works. So private JSON object receive. So client So what we're going to do is we're going to basically do something. I'm going to show you guys how to read kind of read in JSON by first sending in the integer of how long the number of bytes are for JSON text. Well, okay, how complicated do we actually want to do this?
That's not too crazy.
Yeah, because this should just be, this is like 5 lines of code, but do we want to be able to like have the client be stateful or stateless?
I guess like we already like understand what stateful clients look like with that thread you had at the very end. So maybe we'll just go with the stateless
Okay, so if it's stateless, then we'll just do this.
presentation.
We don't need to receive. Okay. So we went from, they're going to have a quit function even though it's the first message, but that's fine. That doesn't matter for us. Okay, so we can have on a client, we'll have a handshake given a socket where a socket and a JSON object request. So given a socket to communicate on and a request, we can then write the entire request to string for, so indent it. Okay. We can write the entire request and then we can receive the response from the server, and then we can close the socket afterwards and return the result. So we should also make the request, so public, yeah, this can be static. Add operation int A and B. Quit operation. Does that line up with our protocol implementation? Type quit. Add subtract, not sub. Okay. Okay, rather than doing socket here, let's just do destination and port. The reason I'm doing this is because that socket's going to be closed by the time we actually send out the request. So let's add, what, 25, 25. Is that the port I was using? 25565, yeah. And, sorry, I'm reducing the amount of code I have to write by taking a little bit more time to make these. Okay. Sub operation, and then quit operation. Okay, Json Server, Json Client. See if all goes well. I apologize for taking so long in this section, but I figured I wanted to at least go over implementing a JSON protocol from scratch, as it's important to have an understanding of. They are running. Something seems to be up though. Oh, here we go. Okay, what is it waiting on? Okay, it sent it, and then on the server side it did not respond. Why did it not respond? Let's run the server, run the client. And then Let's pause the server, see where it's stuck on, what thread was it made. Thread 0. Oh. Thread 0, what is it stuck on? Stuck on get input stream, read all bytes. Whereas this one is stuck on read all bytes. Perhaps it needs to close the output streams, as it's not getting the end of line character. Oh, progress. Interesting.
Did we make the object?
Oh.
That's what I was thinking, like, did we... Oh, okay.
This is supposed to be request. There we go. Basically, the I was using the newly made object and getting A and B from that, as opposed to using the ones I was provided in the request. So you can see here, it is getting the response, but here.
I think it's because like we close it too soon.
Yeah. It's probably because I'm reading all bytes. Okay. Okay. So simple fix. New object output stream or input stream. Okay, so rather than using the output and input stream raw at the start, we're going to make a new object output and input stream. That way it knows to expect a UTF stream and it'll handle that type of communication. We don't have to close it. So we don't have to do this read all bytes thing. At least on the first receive. I don't know if any of that made sense. But it works. Okay. To quickly go over what I just was trying to explain, but explained horribly. At the start, before we had this thing where we did socket input stream read all bytes. Problem is, read all bytes will wait until the very end of a stream. So basically once you close the stream. Problem with that is we don't want to close the stream yet because we need to respond. And so we can only read all bytes when it's the last message being sent. So in the respond on the server side, right here, we are okay to write our final message, flush it, and close it without using any wrapper classes to make communication easier. On the client side, in the same regard, we don't need a wrapper class to receive data, because it's the last message being sent before we close the stream. However, it's the first message of 2. We don't want it to automatically, like, we want to be able to read in the message and then respond back. So we need to put a wrapper class that'll automatically handle the size of the data, telling the other object, or this object output stream tells this object input stream, hey, I'm done sending a message. We're not done communicating, but this is the end of the message. So I'm using this wrapper to basically write a UTF string, and I'm using this object input stream wrapper to read a UTF string, which UTF is a format for encoding strings and characters into bytes. It's a form of serializer. Okay. That was a lot. Are we good on JSON protocols?
More than enough, yeah.
Okay. Sorry for taking so long for that one.
This was practically our whole semester, so.
Practically the entire semester summed up in what was it, 30 minutes something? I don't know. Probably less. Okay. Next on to the proto files. They're pretty easy to read. They start off at the very top. You define what file type it is, so like how should it be read. Since as you can imagine, like protobuf is a library, and libraries change over time, and so they may have different syntax over time. And as a result, the first line in the protobuf file is to set the syntax, basically the version of protobuf that this file is in. Why they do that is that's for like backwards compatibility. So if you have a large software system and you have some files that are in version 3, some that are in version 2, version 3 is able to read and parse both of them without having to change them. That's basically what the syntax line does. Second thing, package. Because protobuf basically is its own language that is being read and translated into Java files, this package is is basically like a Java package. It's where does the compiled Java files end up in your Java source code. So in this case, it's going to be in the Java package tutorial. Now that's what's going to be in the actual class. So like, if you know at the top of each class, you normally have this package line. Normally, and hopefully, it reflects the location, like how many folders it's in from the Java source file. So source folder. So like this Java folder should have 3 folders inside of it, which, why does it not? That's weird. I think it's because it has the periods in it. That's fine with that. Normally you want it to have like 3 separate folders. I think that's just something weird that I set up with. But in this example, you're going to compile Java files that at the top will say package tutorial, but in the actual file location will be com example tutorial. If I'm understanding that correctly, or that might be vice versa. It's hard without a reference, but in short, one of these is referring to the protobuf package. So like, if you're gonna group together all the protocols into one package, the other is referring to the Java package. Then you have the actual Java class name. So like when it compiles the class, what should that class's name be? So like the .java file is going to be named address book protos. So thinking back about it now, this makes more sense that the com example tutorial is the package for the class, and this is the actual class name. So something I've seen that's commonly confusing is that the protobuf file itself, the .proto file, may be named like bob.proto. But the actual class it generates could be address book protos.java or whatever. And as a result, it may be confusing trying to import it and figure out how you extend it and whatnot. So just keep in mind this defines that type of trait. Now the technical stuff out of the way, the actual stuff we need for the exam. Proto files kind of have a series of declarations. You can declare services with gRPC. You can declare messages, which are like basically like JSON protocol messages, things that you'd send over network. You can define enums, which are basically like messages, but they're enumerable ones. They're the same. And it's kind of like having a Java, or it's a JSON object where the key is mobile and the value is 0, and home is another key, 1 is the value. So it's kind of similar vein. Here in this message, you can have like, these are like members. These are like if a person is a class, then name is a string field of that class. Honestly, it's better if I kind of demonstrate like what is this comparatively. So if you make a new class, this is basically a person. When you define this person class, or this person protobuf, it's basically like saying public string name, public int ID, public string email, or enum, public enum, phone type. Okay, hold on. Here. Sorry, let me move stuff over. Resituate the actual setup. Okay. The phone type. You have a phone number class. It's basically just made out of a string and called number, and then the type, which by default is going to be home. And then, yeah, this is basically this entire, oh yeah, there's also phone number. I guess a list is better. Phones. Basically, protobuf allows you to kind of define this kind of class, but also define the tools to build it, to add things to it, to send it, to expect it. And paired with gRPC, you can then set up a service that is dedicated to sending and receiving these types of messages, and basically adding a layer on top of socket protocols that is kind of making it easier as a developer to implement, for example, this like add and subtract protocol that we're doing. Because we don't have to, for example, we don't have to check if a JSON object that we receive is even a JSON object in the first place. We don't have to check if it has a type key and if that type is a string and respond with a specific type of error. Protobuf handles all of that. They basically are like, okay, you receive a message, it'll throw an error if it's not the right message, but if it is, you now have a name, an ID, an email, and a number of phones. Or in a list of phones. And that's it. You can do whatever you need with that data. It's extremely useful for serializing and setting up communication services very quickly. It's definitely recommended over using these like JSON kind of back and forth, as we saw how tedious it was to implement this. Okay. Any questions on protocols and things of that nature?
What's more intuitive to understand, JSON or protobuf? Like, I think JSON is much more intuitive to understand, even though it's kind of like a pain in the butt. But
I think just more
protobuf,
readable for JSON.
yeah.
I
What do you think?
I think the important thing to note is why they exist and what their use case is for. Because JSON, I think, looks more readable, but there's a reason why. It's not made for networking, it's made for abstracting information into kind of a simple human readable format. So of course it's going to look more intuitive to us, right? But it's not complex enough to, like, you can't define an int 30 or like a base 32 int or versus a 64 base int. You can't define small intricacies. Like this is, if you were to send this entire JSON protocol over network, there's a lot more data involved than if you were to send something like this. Because let's say you're trying to send this person message, for example. You can kind of abstract the information down to like, okay, I only need to send the first X number of bytes, that's going to be the name. Second X number of bytes, that's going to be the ID. Third X amount of bytes, that's going to be the email. There's an expected order that you're going to receive information, how large it's going to be, and you can kind of compact and optimize how much information is sent every time you make a request. JSON, on the other hand, doesn't do any of that. It's a string. You're sending a string, you're receiving a string, and then you're parsing that string. That, by nature, is gonna be slower. It's gonna take longer, especially when you start scaling up. But that's not the point of JSON. The point is to be readable. So protobuf on its own may not be as intuitive, but that's because its goal isn't to be intuitive. Its goal is to make it easier for you as a programmer to be efficient with your protocols and be explicit with your protocols. So you hard define how you make an add request and what data types you're using for that add request. So you can change that stuff on a dime. JSON, on the other hand, is entirely meant for abstracting away from any language overall and just providing that data in a, I keep saying it, human readable format. I know that was a lot, but you kind of see where
protobuf is just more efficient, yeah.
Yeah, it's
efficient.
it's a tool dedicated for protocol stuff. So where you might use it, you might use JSON for like for example GitHub. If you want to make simple here, there's a concept called REST servers. So GitHub REST API. So you can basically tell GitHub here. Where is... Nope. Get commits REST API. Okay. So in GitHub, they use something called a REST API. REST is something that you'd usually see when we're talking about JSON protocols. Like, the requests usually involve the request or response is always in a JSON format. And the reason for this is that protobuf is like Java specific. JSON is not. And so you'll see it being commonly used in GitHub, you'll see it in YouTube, YouTube REST API. Here, YouTube search REST API. See, so response is in JSON. Taiga also uses it. You'll see it in a lot of places. JSON is very universal for that kind of stuff. For the forward-facing, which is the term for this kind of stuff, the forward-facing kind of information, where you want the developer that's not part of your company to integrate or to communicate with your servers. That's usually when you'll see JSON. Protobuf, on the other hand, may be used for internal server management. So that's when you want to, YouTube, I don't think they're using Protobuf, but like, let's pretend like they are. They might be using it for updating like counts. They may be using it for keeping servers up to date with each other. Whereas they may be using these kind of, these JSON protocols for listening to outward requests. So Protobuf is more inner server, JSON is more outer server, if that makes sense. I don't know if I just went on a tangent or if I addressed your question.
No.
Yeah, somebody was asking about query parameters. So this actually does kind of tack on. Let's say you're trying to search on YouTube for like a specific type of video. You will have to make a request to their search endpoint. You'll make an HTTP request to their search endpoint. And there's these things called parameters, which are parameter you're familiar with as a programmer, but they also apply to search parameters or query strings, as they're often called. Because when you type in something like this, search equals Bob, this in its entirety is called a query string. The reason we have it is that basically you can think of like you've got your domain, like the server that you're trying to connect to, what provider has that server, and then what type of search you're trying, or what type of query you're trying to make. So you're trying to query YouTube's version 3 search protocol, and then what type of information do you want to provide on top of that? So what about your search? Like what type of video are you trying to find? And that's where you get into, you can add a channel ID. So you can provide it a specific ID for which YouTube channel you want to search for, or search videos for. Or maybe a specific location. And maybe this could be a radius, this could be coordinates. Or even like whether or not you want to have safe search on. Or what type of topic ID do you want to have it be related to? Or what kind of search are you even doing? Are you doing channels, playlists, videos? All of these are part of these query strings. And the important thing to note is that you basically just put a question mark onto the end of the request, and then you put the key. For example, let's do type here. Type equals video, as they say video here is a parameter, and then we do an and sign to separate out these parameters. And I don't know. Here, let's do a embeddable video. And the video duration is short. We got a 403 because we don't have an API key. But in theory, if you had the right credentials to query YouTube's API, this would be the way to do it. As this section, this question mark section, is a query string. and these are query parameters, or query string parameters. Any questions on that? On query string parameters and things like that?
Seems solid. So you just have first you'd write off you just write off the general link, and then you would write the query, and then you would add a question mark to it, and then if the query has particular arguments, you write the arguments in there.
Yeah. So in your example, this is this is the actual like endpoint. These are called endpoints. Every time you have like a slash and then some text, that's a different endpoint, is kind of what they're referred to as. So in this case, we're going to YouTube's v3 search endpoint, and then we're appending search parameters by adding this question mark with the type equaling video, and video embeddable equaling true, and video duration equaling short. Does that make sense?
Yeah.
Okay. So that's query parameters and protocol stuff. Threads. Threads are used in distributed systems usually in a lot of different ways. You can use a thread to basically, anytime a new client connects, so that as to not wait, or so that you can keep accepting new clients, you may create a new thread specifically for communicating with a client. So in this example, that's exactly what we did. We made a client handler thread, and as soon as we get a new socket connection, we start that thread up and wait for another one. This accept method is called a blocking method, which means that it pauses all code when it's being called until it receives this new client that connects or an error occurs. Race conditions are basically where you have two things executing in parallel, both trying to manipulate the same piece of information, and one of them is mutating something while the other one is, well, this is a specific type of race condition, but race condition in general is just when two threads are trying to compete for the same resource, and no, that's a specific type of race condition. It's basically when some condition is based on another thread running at a specific time, because there's technically no guarantee that any thread will run at any time. Like technically the main thread isn't even guaranteed to run in order, because you may have background tasks that take priority. Or you're like the main thread for Google Chrome, for example, I could click on a link, then minimize the tab, and pull up a game. And that may put Google Chrome on pause. So if I had something that was sensitive that the main thread had to do something by 1 second later, or else something bad happens, that would be a race condition. Race conditions happen on single threads, not only multi-threads. It's just multiple threads. The key difference is that in multiple threads, you end up running into race conditions mainly with resource sharing. So when you allocate a resource on one thread and pass that to another thread, if both threads at the same time try and modify that piece of information, or one tries to modify it, the other tries to read it at the exact same time, or possibly at a later time or before that, you end up having this situation where the threads are going to be out of sync or going to cause a modification, like a concurrent modification exception, at least in Java. It's basically fighting over resources. I know I've said the same thing like 4 times now. Is there any questions about that? About race conditions and things like that?
You mentioned that two different two different threads trying to access the same resource is a specific race condition.
Mm-hmm. Yeah, let me...
What other race conditions do we have?
So there are race conditions, hold on, race condition. Let's see if Wikipedia's got a good example.
Because I always thought that was the definition of race condition.
So, there's the type where like one thread is modifying something while another thread is reading it at that same time. So that's one type of race condition. Another one could be like one thread modifies something, then another thread modifies it, and then that original thread tries to read it assuming it's the same value as before, but in actuality it's been changed already, and therefore you ended up with a race, like an issue where one thread wasn't able to finish its task before releasing that resource to another thread to modify it. Is that gonna make sense?
Yeah, yeah.
Like an example of YouTube is like if I basically watched a video and viewed this video, and then somebody else on the other side of the world did the exact same thing on the same video, who's the one who gets to increase the view first? Like if I'm view number 100, and the time that they connected they were also 100, if you're not careful, you may end up with 101 views as opposed to 102 views.
Okay. Yeah, that makes sense.
Things like that. Then you also have you have deadlocking, where in trying to kind of solve this concurrency issue, or this race condition issue, you end up locking your threads in a never-ending battle. So what I mean by that is one solution to race conditions like this, like the kind of resource sharing thing, is to be able to lock a specific resource until you're done modifying or doing whatever you need with it, and then unlocking it. We do this by adding synchronized to a method, but this can be done in many different ways. You probably remember a mutex is one of those.
Yeah, mutex, semaphore, or using the synchronized keyword with Java.
Yeah. In Java, you have many things. You can do synchronized on methods, which will make it so that anytime another synchronized method on that object is called, the first one is the one that gets to run. The second one has to wait for that first to finish. So you kind of have this, hold up, I'm still working on it. Give me a second. Okay, now you're good. That's one way. The second way is to have atomic. You can have atomic booleans, integers, longs, integer arrays, or references. You can have an atomic reference of socket, for example, and then you can acquire it, or was it? What is it? I think it's accumulate or get acquire. So you can get acquire. Now this basically locks the resource from any other thread touching this, and then you can do client.release, or is it set release, and then you can set a release with like a new value or whatever. This is one way. Another way is to have a concurrent. When you're dealing with data structures, you can have concurrent data structures. So concurrent hash map, a concurrent list, or linked list, or linked queue or DQ, or concurrent skip list, a skip list set. A bunch of these. Another way is doing collections dot synchronized list, or set, or collection, and then you can just pass it like a new array list, for example. Synchronized list. And now this list will make all of its methods, like add and remove, all of those will be synchronized by wrapping it in this collection. So like if I did list.add, this would lock this add operation from being called on any other thread.
That saves the trouble of using mutexes there.
Yep, exactly. As you can see, it's basically just calling synchronize list and then doing its operation. Okay. Okay, what is a deadlock? A deadlock is what I described before, where one resource is waiting for another resource to become available, but never will. Well, no, I think that's starvation. Deadlock is where it's, hold on.
Deadlock is when no one is able to get any resource, and starvation is just because they're not getting any resource, they're just waiting and waiting and waiting, and they end up dying hungry.
Okay, yeah. Okay. That's such a weird...
Yeah, you'd think deadlock would be a product. Starvation would be a product of deadlocking, but...
Yeah. So it's more like... Yeah, two kind of two dependent resources are depending on each other. Kind of. No. A thread is making use of one resource, and it requires another resource that another thread is currently using, and they are also depending on that first thread's original resource. So basically, thread 1 holds something that is locked, and thread 2 holds another thing that's locked, and thread 1 requires the second thread's locked thing, and thread 2 requires the first thread's locked thing. As a result, they're both needing locked things, and they've locked themselves waiting for the thing that's, yeah. It's like a cyclical locking thing. Whereas starvation is like, you just can't get anything in the first place. You don't have something already, it's just you can't get it. Because it's just never being released. Which I think the dining philosopher's problem is related to starvation.
Yeah.
Like, alright. Do threads run truly in parallel? No. Thread pools are important, so you limit the actual number of threads that can run at a time. I think... Is that the answer she's looking for, though? Thread pools...
Yeah, I think she mentioned in class why we want to have thread pools, is so that we don't like completely exhaust the server's resources. Because, making threads is kind of like computationally expensive, so...
You also have a limited number of them. So you don't want to have 2,000 threads dedicated to... Well, like, you don't want to dedicate more threads than you have in the first place. And you also want to make sure that you leave enough threads that you can... Let's say if you have internal... Like, if you have a server that's dedicated to updating your information, it's like a caching server, you want to make sure that you're able to still receive information even though you're handling clients. So your worst case scenario is you stop accepting clients because you're at max capacity, but you can still listen to that caching server that's going to update you with recent information. So you want to still be able to do your job while also being able to handle threaded tasks. Distributed algorithms. Advantages, I mean, if you look in the cryptosphere, like the entire idea behind a hashing algorithm, like a 50% or more people can all agree on an answer, then that answer can be done, it can be widely accepted, and therefore, like, you basically have a system that doesn't rely on the one central server to kind of say this is true or false, meaning you can't really fake things added to this system. However, or at least it makes it very difficult. However, there is disadvantages to that, because if you have 50% of the network, you technically can take over that network and falsify information, as you are more than 50%, and therefore you can make you can basically forge a vote in favor of something that's just not true. It's kind of like if you basically asked half of the entire society to vote one way. Like, it's extremely difficult to get half of a society to vote a specific way. But if you could entirely determine the outcome of that vote, basically. That's the idea of like a what is this? It's not a leader election. This is just like isn't there just like a voting? Is there a name for that? Like a specific distributed algorithm name?
It'd be leader election, right?
Leader election implies that there's a leader who also controls. Like.
Right.
That's more like central. It's a consensus algorithm. That's what it was.
Oh yeah, consensus algorithm.
So that's a consensus algorithm. A leader election is basically where you basically have leaders in a network that are responsible for controlling certain things. So like, while I do say crypto is like a consensus algorithm to some extent, when you make your own crypto token, you can basically elect a leader that handles transactions. So like maybe the way it handles it is public, however, you still have a leader node responsible for making kind of transactions.
All the major decisions.
Yeah.
Okay. So it's kind of like in our assignment 5, that well, it really depends. I don't know how everyone else did it, but I had like a central system that sent in the votes, asked for transactions and all that stuff, but just in multiples.
Yeah, you basically have this leader here. The client connects to the leader. And then the leader communicates and does a consensus algorithm between all of its nodes. And basically, every time a client requests for something, you do a consensus on what that response would be. And the leader determines, okay, that response was valid, that response was invalid. Or not even the response was valid or invalid, but rather that response was processed or that response was rejected. So like making a request for like money, for example, you have to have more than 50% or more of the network to say, yes, we can afford that. And then the leader's like, okay, please, this person is going to request or is going to take out this amount of money from all of you, split amongst yourselves. And then the leader responds to the client saying, hey, this is the amount of money that you now owe, and whatnot. And each one of these kind of have their own kind of their own logs and turn operations, but this is basically the person who speaks for everyone else. We've done some different distributed systems. We've done systems where it's just client to server, straight up. We've done ones where it's multiple clients to one server. That leader protocol was one client to one server to multiple peers. So it's we've done a handful of these. But yeah. Any questions about this before I move on?
Okay, what's the disadvantage of having these distributed algorithms? Like for one thing, I can see that it'd just be so. It just would be like a performance slog, right? Because we were just waiting on multiple inputs.
Yeah.
What else?
So there's that one disadvantage is that you're having to do mass communication, and therefore you're gonna have to wait for people to respond. So you basically you have a lot of dependencies on other people for your job to be performed. Not only that, you also are solving the problem. You're having to solve the problem of like concurrency, where like you need to determine, okay, are these synchronous operations? Are these asynchronous operations? If they're asynchronous, how are you going to collect that data? How are you going to determine the result at the end. Another disadvantage is bandwidth. The amount of information that you're sent is multiplied by the number of people you're actually communicating with. I mean, the advantage is you can split a problem up among a lot of different people, but the disadvantage of that is it can be pretty costly. I mean, I keep going back to crypto, but like, everybody can solve a specific challenge to quote-unquote mine some kind of coin, but the disadvantage of that is it can use a lot of power. It ends up being pretty detrimental environmentally because it is it's an extremely taxing algorithm. And then you multiply that by a number of systems that are trying to solve the same problem, and you're kind of expanding that problem. Whereas if you don't do that in a distributed environment, an example of like, I've seen games where they've tried to move to like NFTs, for example. Like,
Oh God.
the solution that problem is trying to solve is already possible without distributed algorithms. You can like, for example, Steam already has an item system, an inventory system. You can technically transfer items from game to game, but that's entirely up to the developer's implementation details.
So
Whereas,
would you say there's a lot more overhead in using it?
Yes. There's a lot more overhead overall with distributed algorithms, because it's not just one computer, it's many. And it's not just one problem now, it's split up between many. Okay. Any other questions or comments about the distributed algorithms?
Seems solid.
Okay. Middleware. What is middleware? From my understanding, middleware is basically the software that kind of acts, it's kind of like the drivers for computers. It's like the equivalent of it. It's the software equivalent of drivers. That's my understanding of it. Let me look up the definition.
Isn't it like the middleman between software and hardware, or?
Yeah, I think it's even more than that. That's what a driver is. Well, so actually, let me kind of back that up. You've got your computer here, right? And then inside of there, you've got your like components. Like this will be your this is like the physical bus that your keyboard or mouse is plugged into. Then you'll have these drivers that kind of sit here. So you got your drivers there, you've got your physical keyboard and mouse inputs. So these basically are like at a bit level. So you're basically sending bits in and out. And then here you've got your operating system. You got your Windows, your Mac, your Linux. And then here you have your kind of your language of choice. In this case, it's your Java/JVM/programming language. Depending on languages, you won't have this layer. For example, like C or C++, C#, you don't have this layer. You're directly operating with the or interacting with the operating system. And also there's layers I'm missing here that I'm not going into detail about, but I'm just trying to do some abstraction. And here's your actual software. So like, let's say you have, if you want to listen to keyboard inputs, you don't have to listen into every byte that comes into this layer. That would be ridiculous, and nobody wants to do that. Rather, the keyboard inputs get fed into the hardware of your computer, which kind of do go through your operating system and go through your drivers, which get translated and have like an interface on the actual Windows side of things. So your operating system has the ability to detect when keyboard inputs are made, but that those kind of are only triggered by drivers. So kind of drivers are this middleware between your OS and your physical keyboard and mouse inputs. That's why every time you like plug in a new device, it usually says something about drivers and installing drivers and having to update your drivers. It's because there's a middleman that is supposed to keep the information in and out up to date. Now, where does that put us in the software? Well, middleware in our software is kind of like, it's not, it's a little bit farther, it's kind of in between here. So your middleware kind of runs at this level. So this is an example of like, let's say you want to have a SQL driver. Your middleware will help you communicate from your software, your programming language, to, for example, SQL. That's maybe running over here. So your middleware makes it possible that your software, your Java API, your Java library, or your network requests can be sent to this SQL server. Basically kind of acting like a proxy almost. Does that kind of make sense?
Yeah.
I just want to give a chance to ask questions.
Like, does that ensure, I don't know, translation between systems? Like,
yeah,
I guess that's the whole point with distributed, this whole course, right? Distributed systems. So, does the middleware ensure like everything gets translated across every system, or will there still be hitches there?
It is basically it's not just systems. You're right in the fact that it is a way to like translate between layers. This is basically a translation between Java, Python, whatever, to communicating with SQL. So this could be Java, you'd be running Java, Python, or Rust, Ruby, whatever, and then communicate with the middleware, so that way you can communicate regardless of language. So you can kind of think of it as like it's kind of like our JSON protocol, but for translating things. It's like our type is not add or subtract, it's translate this query to an SQL instruction.
Okay.
And so it's kind of used for, let's say you want to, here, let me actually pull up when I search up RPC middleware. So like a remote call procedure is a protocol that one program can use to request a service from a program located in another computer on a network without having to understand that network's details. Like a procedure is also sometimes known as a function call or subroutine call. So you can kind of, you set up a way of communicating that can also mask that other system's way of communicating. So like, you don't expose how to directly communicate with this other server, but you can still communicate with it. Does that kind of make sense?
Yeah.
Okay. So gRPC is a specific library for these RPC middleware, and it's just...
It's Google's, right?
It actually, is it? I don't know.
I think that's what the G stands for.
Yeah, it was developed by Google, yeah. Yeah, you can see it's done in Go, C++, Java, Python, and a bunch of other languages. The idea being that it's I mean, the marketing kind of explains it. You're basically defining services, which is some expectation or some request can receive some type of response, and it handles the communication between languages as a result. It also provides a bunch of other stuff, which a bunch more technical stuff. Like they had mentioned, like network stuff and like masking of information. Because we just like did gRPC between Java and Java, it didn't really matter. Or not that it didn't really matter. It didn't really become apparent how this middleware was working. But had we just run our gRPC client in Python, like our server was in Python and our client was in Java, I think that would have been a much better kind of demonstration of what a gRPC is good for. Like how you can kind of communicate between two platforms without having to be using the same platform. If that makes sense.
Yeah. We're talking about in regards to like assignment 6. I guess she didn't want to get that crazy with assignment 6 because it was like towards the tail end of the semester. So
yeah, assignment 6 in general was it was all about like gRPC stuff, which because that I'm gonna pull up some of the stuff from that assignment just as a reference for protobuf stuff. So you see this, like this is standard protobuf stuff. You see this is protobuf version 3, not 2. I don't really know if there's any changes from that, but basically, the important things, the new things is this server service, or not server, this service Caesar. This is a gRPC added service, which has a remote procedure call encrypt, which takes a message, save request, and returns save request. So basically, she wants you to be able to read these. So you can kind of imagine, like, in our example of our JSON, let's actually take our JSON example and turn it into protobuf. I think that would be a pretty easy thing to do. Like, not actually implement it, but like demonstrate what that looks like. And then from there, translate that to gRPC. So here, new simple server proto. So we'll do as reference syntax proto 3 package proto. This stuff we'll ignore the option stuff. Do service, and we'll name the service. What do we want to name it? Math. Call it math. And then Copilot's kind of catching on. Where we had an add operation before, we're going to have an add operation again, and we're going to have some kind of add request that returns some type of add. We're going to have a math response actually. And then we're going to have an add request, and actually let's change this from add request to just math request. And we're also going to have a math response. And then
let's also have a repeated field.
What?
Let's have a repeated field that uses empty, just for posterity.
For which? For, oh, you mean an
let's
operation?
have yeah, like have a list of all the previous calculations that have been made.
Okay. List list empty. I think, is it empty?
It's just empty.
Oh,
right?
because it's, I remember now.
So you have to get empties library.
Let's pretend that this import works. uh, google.protobuf.empty. There.
There you go, it works.
So this is one thing. This Copilot suggested something called stream of math response. Technically, this is like a repeated field. I don't know if you can do... No, you can't. So this is basically like, if you remember input stream, output stream, you can have a stream of any arbitrary type, and this is kind of an example of that. You can have a stream of math responses. Alternatively, you can have a math history message that has a repeated math response, and so this is just has math history as a response. And bada bing bada boom, we've now basically defined all the protocols that took us 30 minutes in probably about 2 minutes. All we'd have to do is like actually implement it, which would basically just mean running a Gradle, creating a new class, extending a class, and writing like maybe, or overriding one method, and it would be really simple, is my point. And that's the main reason why we want to, we like using services, and we like using RPCs, and gRPC is one specific implementation of that. Yeah. Any questions on gRPC, RPC, middleware, and whatnot? Okay. Let's do some quick example questions and we'll call it a night, okay? What port does HTTP use? We answered this earlier today.
Yeah, sorry, my mic is muted. So for the part where it says what is gRPC, is it just an easier way to implement client and server?
gRPC specifically is a Google developed library that is an implementation of a concept called RPC, Remote Procedure Call, that allows you to provide services that are language independent and independent of platform, or kind of, I think that's basically it. So gRPC specifically is a Google remote procedure call. RPC as a concept, though, is just a form of providing a service that is middleware for your program to communicate with some other machine that hosts that specific service or that specific operation. So like in this case, we have an operation add, an operation subtract, an operation list. All of those are remote procedure calls, and gRPC in this example is our implementation of that service. That was a long-winded response, but...
Okay. And so when it's saying for explaining the workflow of gRPC, is that just asking for how to set it up?
I believe the workflow is implying how information is sent and received. So like, in this case, if I have a client and server, a server starts up by creating a service called math, and it has 3 procedures: add, subtract, list. A client starts up. The client sends a remote procedure call for add, using a math request to the server. So you have information that is sent to the server, which gRPC in this, well, yeah. That request is then forwarded to the server that was listening to that request, and then it responds with a response, math response, which then is forwarded to the person the client who originally requested it. So it's kind of like the, I think the middleware example is that there's always somebody in the middle. In this case, gRPC, I believe, is the one in the middle. However, the flow is basically client to middleman, middleman to server, server to middleman, middleman to client.
Okay.
Does that kind of make sense?
Yeah, I can see that.
It's kind of like basically how you communicate with your router. Your PC talks to the router talks to the person, and vice versa.
Yeah.
Okay.
It's kind of like the consensus algorithm in assignment 5. Client requests.
Yeah.
Sends a request to the leader. Leader sends a request to the banknotes. Banknotes reply. Banknotes. Leader sends. Yeah, you get the idea.
Yeah, no, you're dead on. You're spot on. Like, it's basically exactly that, but maybe you don't have 5 nodes that the bank is connected to. You just have 1. Okay. Are you good on middleware?
Yeah, should be good.
Okay. Example questions. So we talked about what port HTTP uses. That's 80. HTTPS is 443. The difference is that HTTPS, technically, the difference is that HTTPS sends a certificate and has is encrypted with public-private key encryption. However, for the sake of this class and this final, HTTPS, S stands for secure. Secure means encrypted. Pretty simple. Hypertext Transfer Protocol versus Hypertext Transfer Protocol secure. Pretty simple difference. In your code, when creating client and server, do you need to specify the client IP and port in your server code? Why or why not? Server does not need to know its own IP unless it's application specific. It does need to know what port it is going to be open on. A client needs to know what IP and what port a server is in order to connect it. Otherwise, you have no idea like who you're going to connect to. You're just going to keep asking. You're going to go door to door asking people, "Hey, can you handle my math request?" Like, that's not how it works. You need to know where you're going to knock first before you go knocking. Which is a weird analogy, but basically this is false. You do not need to specify the client IP and port in your server code. You need the server IP and server port in your client code. And if at any point you want to stop me during this, please do so. I'm going to try and speed up, but if at any point you want me to go back to something, just say something. The difference between private and public IP. Private IP is basically the devices on your network, on your router, have a private IP. The public IP is the IP of the router itself. So anytime your private IP, your devices try to communicate with the outside world, it has to go through your router. And that router is going to send people its public IP. But in response, your device has to be the one to determine, oh yeah, that message is for me. I want to receive that message. And that private IP is the one that kind of figures that out. I don't entirely know where the private IP gets attached, or if it does at all. I don't know if anybody here knows that, but at one point during the communication between your computer talking to the router and the router receiving information and talking to your computer, a private IP is kind of associated with your message, from my understanding. So like your computer uses that to basically figure out, oh yeah, I was the one who made the request, I'll read it now. But the important thing to know is that everybody in your network gets a copy of that traffic, which is why Wireshark lets you see all traffic on a network. Which of the following some list are considered upper layers? Select what?
I think it's like she'll give us a diagram of the OSI layers, and we have to, or like the names of the OSI layers, and then we have to choose which one are the upper layers. So off the top of my head, I think the application layer, the network layer, the transport layer, and the data link layer are the upper layers, if I'm not mistaken. Yeah, there's the OSI model. Oh,
yeah, 2 out of the 3. Network layer and data, or 2 out of the 4. Network and data link are media layers, or kind of application layer
layers.
is application presentation. Wait, she uses different titling or naming.
This is just the diagram.
Yeah. What was the original question? This was...
Yeah, so the upper layers of OSI model, according to quick Google search I did, is application, presentation, session, transport. What? Wait, that's the whole goddamn list.
Yeah, no.
Okay, there we go.
The host
yeah,
layer
my
is
bad.
the
Not
upper layers, media layer is the lower layer.
Sorry, I found a better diagram. It's application, presentation, and session. That's the upper layers.
Okay, so that's the data layer in this, or the data unit.
And then everything after that, the transport, network, data link, physical, those are the lower layers.
Okay, that makes sense. Just make sure to have those in your notes.
Yeah, obviously. Yeah, I've been writing those.
Okay, HTTP protocol is stateful. No. I mean, kind of, but no. Cookies don't count as stateful. When you make a request to a server, you get a response back that is completely stateless. Modern internet, it's becoming more stateful, but that's not part of this quiz. The semantics. This API explains different parts of the URL. HTTPS is the protocol that you use to communicate. GitHub is COM is the domain name service that is going to resolve the domain api.github. API is a subdomain. The endpoint that you're making a request to is repos, a mailhouse, memoranda commits. The search query, or the the URL search parameters. I can't remember the name of it now. Gosh, what was the name of it? Search query? Search parameter? Search?
I think what she had it down earlier was just the host path and query, I think is what she wanted
Query
us
string.
to know.
Query string.
Host path file, query string.
Yeah. So this is query string. This is, if she says this is file, then that's fine. It's endpoint is the technical term. File is also, I think, would be valid. And the host is COM to API. Okay. Question, can a port have many socket connections? A server socket can have many socket connections on its server port. However, its client, like the client cannot connect to many, or one port cannot connect to many other, well, this is just yes. Yes, because a server can accept many sockets on its port, yeah. Thank you. My brain's starting to slow down. Assume you have a client and server. The server runs on port 8000. What does the client run on? We don't know. How do you know? We don't know. Who sets it? Java.
It's gonna be like from between like 41,000 to 60,000. I'm not too sure.
It's going to be within the safe range of ports. Unused port range. 49.
Yeah, 41,000.
Yeah.
To 60.
This range.
Wait, aren't those the? Aren't
What's
those
up?
the reserved door ports?
The reserve ports are less.
Oh, okay.
These are dynamic ports.
I think the reserve ports are like from 1 to 1,000.
Yep, 1024.
Oh, no. I thought they were private ports as well. Like only companies use these ports.
Well, there's ports in the range 1024 to 49,151 that are assigned or controlled. But you can register them to prevent duplication.
Oh, okay.
So you basically have three ranges. One that are assigned and controlled, one that are not assigned but controlled, the other one that is not assigned, controlled, or registered. So these are the ones that Java randomly assigns. These are the ones that your applications will probably run on, and this is the one that Windows will probably use. Or will have, no Windows, sorry. These are the ones that are probably going to be like the UDP, TCP, HTTP, HTTPS, like the standard protocols, SSH, all that kind of stuff.
Okay, yeah, that makes sense.
I'm pretty sure, what is it? SQL default port. Yeah, it's 1433. So it's in that designated registered range, right?
Yeah.
Alright. Okay, that answers that. What information does the client need to connect to a server? Technically, just the IP address and the port. You can also know, like, if you have a domain name service, like for example google.com, that goes to a domain name service, com, and then resolves to a IP and port. But bare bones, you just need an IP. Well, okay.
IP, yeah. IP names, IP addresses are basically the domain names.
Yeah. Because like to establish a socket connection, you do need the port, but the difference is that you technically can connect to an IP with just the, or a server with just the IP, because you can route them to a specific port. Does she want to say that you just need the IP or just IP and port? What has she said in the past?
I think as long as we mention that we need a domain name or IP address and port, that's all that's required. I don't think we need to go anything beyond that, right?
Alright.
As long as we get that connection.
Yeah. What are in and output streams? Name two different kinds of streams. Input and output streams are basically an abstraction made by Java to abstract the byte stream coming in to a specific resource or coming out from a specific resource. There are wrappers for it, wrappers with a W, not with an R, that you can use to either wrap and send Java objects or, for example, Java input and output stream, as we saw earlier. There are buffered input and output streams for making sure that you send and accept a specific number of bytes, that you don't kind of exceed that amount. You've got other wrappers such as file input stream, file output stream. You've got what are some other ones?
Data object input stream, object output stream.
Yep. Channel input stream, buffered input stream, chunked input stream, checked input stream, data input stream, empty input
Oh,
stream,
God.
file input stream, filter
Empty?
input stream, HTTP input stream. All of these are input streams. And they probably also
I
have a
guess-
counterpart with an output.
I guess we just pick one and then explain what we like.
Yeah. I'm going to probably mess her up and say a zip input stream and a zip output stream and probably an empty input stream and an empty output stream. That'll be fun. There's also zip.
You have to Google your answers.
Yeah. Anyways, you just gotta name 2 different types of streams. Assuming you have the following task for a client-server application, client can send a shopping list to the server with a list of things the client wants to buy, e.g. apple, banana, chocolate, and the quantity of them as well. This is just an example. The server will then check, basically verify, if the items are available in the required quantity and will return a list of items that are available in that quantity and another list with the items that are not available in the wanted quantity, and the information in case an item is not even in inventory at all. Example, a customer wants and server has can, of course, will be totally what the server wants and server has can, of course, be something totally different. Commas. We need commas.
German, man.
What?
German's.
Yeah, she's German. I understand. Customer wants 3 apples, 2 bananas, 10 chocolate, 1. That's a German word, isn't it? Donor.
Yeah.
Server has 2 apples, 2 bananas, 20 chocolate. Server replies that it's available banana and chocolate, it's not available apple, and it's nope is donor. Design a custom protocol for the client and server application for the request and the responses and explain why you chose this protocol. Choose any protocol type you like from the ones we covered in class. Also make sure you have appropriate error responses. Remember all those that we discussed about custom protocols. You should not create code on what the custom protocol design. So how would the JSON protobuf XML or gRPC look like? She has XML on here. With a detailed explanation. If you do not explain your protocol, you'll not receive points. We did something similar, but do you want me to go over this? I can do a quick little protobuf one if you want.
I think the protobuf would be the quickest.
Okay. This is a shopping list .proto. Let's say we've got a service called checkout. We don't need gRPC, but I do want to do this just for the sake of things. Check out with a shopping cart, and it returns a checkout response. So we have a message shopping or message shopping cart. This isn't string. We also want a message item. So a string name, a quantity, no price. Is it? What am I doing wrong here?
I think it's because you haven't defined an item. No, that can't be it.
Oh. Well, no.
I think it's probably because you didn't define proto syntax or something.
Oh, you're right. That could do it. Syntax. Proto 3. There you go. Thank you.
There we go.
I think because Proto 3, if you don't, or the default Proto, it must be required by default. But whereas with Proto 3, you don't have to define that, and just by default, it's no longer optional. Is there a default value? There definitely was, right? Hold on, I remember seeing this. Oh, it's in brackets. That's so weird. There. Oh, lovely. Okay, never mind. We have no default values. Don't worry about that. Who needs default values for this? We're not implementing it. Okay. Repeated, not string, item, items. And then we're gonna have, yeah. We're gonna have a message response called checkout response. Which doesn't have a message, it's gonna have repeated item available, then unavailable, and then
That'd be a boolean if it was not there.
unsupported.
Okay, no, that works too.
Or if we don't have the item, it's unsupported.
Unsupported donor.
Yep. And then we can have what? Checkout item turns. Something like that if we really wanted to.
Maybe it could be empty. But oh wait, right, we don't. I mean,
you do need to send an item. Unless you're
right.
caching the shopping cart, but that would imply that there's some understanding of who this is, which there's not.
Oh, okay, okay.
Okay. And there we go. Simple protocol, easy enough. Actually, we could probably do let's just do a purchase item. There. I think that's a little bit better.
Maybe even add like a repeated field to show what items you purchased.
This in this case, purchase item is a singular item.
Oh, we just okay.
Which you can actually you do purchase request name, and we could do like a repeated item items, which means we don't need quantity. Purchase request, and we have a purchase response. Basically saying that like if you've checked out and everything's available, then you can purchase those items and we'll tell you if it's successful or not. If it's not, we'll send you an error. Make sense?
Yeah, seems solid.
Okay. In Java, the library we used, how would you get the artist value? Yeah, you create a new JSON object from the string. You get the string. No. You get the object album, and then you'd get the string artist. So by doing get object or new object, you basically create this. And from there, or this is new object in red. In blue, you have get hold on. Let me backtrack as well. When we do new object, we get in red, the JSON object there. When we do get object album, we get this object here, which is better in blue. Okay, where is the end parentheses? So visually confusing. Oh, it's because it's not fully in the frame, that's why. Okay. And then when you want to get the actual artist, you have to get the string artist. So that ends up being this one. This one does not work.
You just only get, oh, that won't work at all, never mind.
Yeah, no, that will throw an error that you either it does not have that key or that it cannot be casted to a string. One of the two. Okay, example questions. Threads always scale our servers? No, not true. That's the keyword always and tests is always red herring. This means false usually. Somebody asks you, is it always like this? Usually it's gonna be false because it's the keyword always that, like, there's specific edge cases where it's not. Like threads always run truly in parallel. Truly is another one of those ones where like truly in parallel, no. Those are kind of like hints to say like, hey, no, this ain't true. It's always it depends. It's usually the answer. It depends. Okay. Threads and processes are the same thing. Not correct. Threads, hold on.
Don't threads run processes?
Hold on.
Processes are like a set of instructions, aren't they?
Yeah.
This is a thread. A process is or contains threads, and kind of is not technically a thread in itself. It just contains threads. A thread is part of a process, but it is not a process in itself. Does that make sense? So like the best way to think about it is go to Task Manager. This is a process. These are sub-processes. These sub-processes may have threads. I think that's the kind of the gist of it. I don't actually know. Are these? I don't think these are threads. No. Yeah, you can see command line. These are processes.
So a thread is an addition to a process.
Yes.
Okay.
Which
that's cool.
You can see I have in total 10 apps, 67 background processes, and like, hold on, 96 window processes. So that's like 100 or something. My CPU tells me I have 4,517 threads active right now. That's like an entire degree larger number of processes than threads. So you can see 260 processes, basically 4,500 threads. So different. Process has threads, thread is not a process. We good on that?
Okay.
Alright. Name one option to make a method in a server thread safe. What? Name one option to make a method in a server thread safe, comma, thread safe. Okay. We talked about it earlier. You make it atomic, you make it concurrent, you make it synchronized, you synchronize the methods. All of these are valid options. Choose whichever one you're most comfortable with. The key thing with synchronized is if you want to make a resource synchronized, like let's say synchronized resource, let's say we have some resource, public or private resource. If we want to recreate that like atomic operation, like resource get resource. Public set resource. Modify resource. Modify replace resource. What is it? Hold on. It's a function that takes or it produces a resource but takes a resource. Oh, resource. No, void. There we go. So by adding synchronize to these modification methods, but also the get methods, we kind of make sure that nothing happens with it. So we can also do like public synchronize safely run consumer So all of these basically, let's say we want to save I don't know, whatever object we wanted. Let's say it's a grade sheet. I don't know, a grade like a let's do like a class. No, classes are let's just do a report card. So let's say we have some synchronized resource that's a report card. In order to like, I don't know, average everything in that report card, we may run this safely run operation so that if anybody else wants to access this report card, they can only do so after we've safely ran our operation, after we safely average their report card or something. Or if we want to replace their report card, so if we want to update it, we can safely update the report card in an environment where no other methods are able to occur while I'm replacing this. This is therefore making it atomic and therefore making it thread safe. Questions on this? Okay, moving on. Last set of questions, then we're done. Sorry for taking so long. I know it's been like 3 hours. I'll remind everyone to eat something after this, but...
No, it's totally fine. It's a lot of stuff to cover.
It is a lot of stuff. It's an entire semester's worth, but I appreciate you sticking with me. Okay. What is an advantage of using distributed algorithms? Didn't we already talk about this?
Yeah, I think that one you can just split up the workload.
Yeah. And then when should you use distributed algorithms? When
you split up the work?
Yeah, when you need to split up the work and it's not feasible for one machine to carry all that work. Or when it's not feasible for that information to stay on one machine. So like if you, for the example of the bank thing, you want to use a distributed algorithm when you have to find good deals on several different banks. Like you can't just have all the banks in one computer. That makes no sense. Like you're not going to have Chase Bank and Wells Fargo all working within one PC. Wouldn't really make sense. So you want to use a distributed algorithm to communicate with both define good deals. The basic concept of a consensus algorithm is you ask a bunch of people a question, those people respond individually, you tally up those responses, and you respond to everybody saying, hey, we've come to a consensus, this is what we should do. And that's a consensus algorithm. Basically, what you think of when you hear the definition of a consensus, where everybody comes to the same idea, or majority kind of vote on a certain thing. Yeah. What are the pros and cons of using a leader in your network? Pros, you can basically, you can have almost like a synchronous, well, you can have one kind of source of, you have one person for like your central thought process, kind of like your central operation, that it then splits up that task into many nodes. However, the cons of that is that if that leader goes offline, trying to figure out who next should be a leader is its own thing, and also it's a single point of failure in general. It also doesn't scale too well at least. Like it can, but like at the same time can't. Like you can have multiple leader networks that like each leader communicates with other sub-leaders, but like that's scalable, but like in terms of adding a bunch more nodes to that network, it's not necessarily scalable. To one singular network, I mean. Naming 3 false assumptions often made in distributed systems and explain them. Crypto's good. No. Let's see. False assumptions. It's easy to implement.
It's efficient.
Yeah, it's efficient.
No, yeah,
It always makes things easier.
it's reliable.
Yeah, it's always reliable. Let's just take this from this perspective of like end user. What do you mean? Distributed systems? Oh, they're easy to implement. They're like everybody implements them. They should be easy. They're simple. They're reliable. They're always up. You know, definitely not a headache for a lot of people.
Not a headache to implement.
Yeah, definitely not. Not at all. I mean, you can basically just make up false assumptions at this point. There's no like master list of false assumptions made. Hold on. False assumptions made about distributed.
I mean, so long as you're not saying like distributed systems are.
Here we go. Network is reliable. Latency is 0. Bandwidth is infinite. Network is secure. Topology doesn't change. There is one administrator. Transport cost is 0. Network is homogeneous. Fair enough. Wikipedia's got me covered. What were you saying, Dave? Or yeah, Dave.
Yeah, no, I was just I mean, for her, as long as you can justify your answer, she'll consider it. She doesn't have like a great grading scheme or something like that.
Yeah.
Worst something really obvious.
Yeah, worst case, it's a short answer. You just explain your thought process. Best case, it's a multiple choice and you explain the obvious ones. Or you just select the obvious ones. Okay. That's all of this review document. Are there any remaining questions? Anything that you want to see talked about? Y'all feel ready?
So, yeah, I just want clarification. Why are threads not always parallel?
So your CPU, and coupled with a couple other factors, chooses what threads can run. So not only is it the fact that like your CPU can choose what threads are running at one time, your CPU may not even be able to handle more than one threads every cycle. So imagine you have a 12, like in my example, I've got a 12 core processor. I have 24 logical processors, which means I can handle 24 separate threads simultaneously, or in other words, I believe 12 processes, 2 threads each. I can run those instructions every cycle. Now, imagine I had 1 core, and I can only handle 1 thread. Only 1 thread at a time means they are not happening in parallel. With my CPU, I can run 24 things in parallel in the exact same instant, not just within the same second, but the same exact instance. That is not guaranteed, especially when I have 4,600 threads. There's no way I'm running all of those in parallel. That's just impossible. There are some factors that can make it more likely that a thread is to run. For example, Windows by default will prioritize apps over background processes, as apps are the things that you want to stay responsive visually, as it's the things that are constantly changing and updating in front of the user, and as such you want to have priority on those processes. So they're the ones who get in first when it comes to CPU load, then the background processes can go. So typically if you look at like the CPU percentage, a lot of this is stuff that is active. Every now and then you'll see a background process jump, but usually the thing that is focused, or the thing that is right in front of the user, that's what's being prioritized by the CPU. That kind of makes sense.
Yeah.
Okay. Any other questions? Any follow-up questions? Okay. I think that's it. Let me stop my recording.